Michael Bihonic with Apache. One problem we have in the drilling industry is the environment is pretty tough on us. Being not only outdoors in that type of environment, but high vibration and things like that. Can you speak to the maturity of sensor development in that regard?
Yeah, sure. So, we deal with a lot of the same sorts of problems, right? And especially in mobile systems. So, like those unmanned ground vehicles and so forth. And it's a classic problem where whenever you have something that's mechanical, it tends to fail over time. So the DARPA Grand Challenge and Urban Challenge vehicles, they all use these scanning LiDARs. These basically you have a laser projector which rotates, and over time, inevitably, those things failed. Moving forward, there's things like more solid-state solutions, so like the Kinect, right, which tend to have higher reliability, at least from a mechanical standpoint. So the Kinect is nothing much more than an LCD panel for the projector and a camera, right, all solid-state solutions. One of the real challenges, though, is because now you have such a more complex data stream, being able to reliably manage or interpret that data is still an issue. So outside of the reliability of the sensor itself, can you adapt the data processing or the perception algorithms to deal with a complex or changing or dynamic environment? So the Kinect is not, it's an interesting product and it's a game changer in some markets, but it doesn't work reliably in sunlight. So you're not going to see that on an oil rig in the near term. But because everybody has seen the light in terms of how this can go for the robotics industry, there are organizations now that are working on more reliable solutions that deal with the kinds of challenges in reliability and uptime that are required in industrial settings. So that's why I kind of posed the question there in one of my slides, that whether or not these types of sensors and these types of solutions are really ready for industrial environments. And in some cases, yes, they may be, especially if you can constrain the environment to minimize the changing nature of them, or minimize the requirements on the reliability of the solution. In other solutions, they may just not be ready.
Charles Piper with IDE. Two-part question to follow up on that one. Are most of the sensors for the human interaction with the robot, are they mostly optic-based? And are they moving toward more sensors that are not such optic-based? In the oil field, dirt, pipe dope, just oil in general, tend to mess with the optics. And the second part is, how far along are y'all with the ROS, the Ross Industrial, with the PLC type communications to where it'll be easily integrated into the existing rig systems, more of the legacy systems?
Right. So yeah, the first question is optical sensing solutions. So yeah, typically, I'm just trying to think of any examples where they're not using an optical solution, and I'm not coming up with any. They're either typically some form of LiDAR, so a laser-based solution, or a camera-based solution, both optical systems. And so you're absolutely right. In your environments, many times optical solutions just aren't going to be viable. We deal with that in that paint stripping robot that I showed you in the very beginning. It uses a blast process, which creates a ton of dust. You basically can't use an optical sensor. So, we're going to take baby steps in terms of implementing this, and go after probably the simpler applications first that allow us to use those kinds of sensing solutions. The second question with regards to the Ross Industrial program, it's really in its infancy. We've basically just started collaborating in the last probably 8 months or so with Will Garage, and we've done implementations now on a few robotic controllers, but have not gotten to, say, PLC-based control systems. we do have that in the vision, and that is part of what we hope to do with this consortium, which we're trying to put together, is to really build out that framework to cover the broader gamut of industrial control systems. We're not there yet.
Hi, Clay. Frank Chum from Chevron. Of the control system automation that you do, how much of them are involved with optimization, such as model-based optimization?
Yeah, I mean, optimization is a core capability in a lot of machine learning and perception algorithms, right? So, I'm trying to think of an example where I had up there, but so, for example, in an object perception pipeline, so where you're trying to recognize a known object in an environment, that's typically an optimization problem. You've got a very high dimensional space, which might be this 3D view of the world that you've created, and you're trying to do a fit of some model, which would be this object that you have interest in, to that 3D world. So that's a classic optimization problem that's used all the time in robotics. It's a really common framework.
Okay, thank you very much, Clay. Excellent presentation. Thank you.
Great stuff.
Work on the video.